Okay, looking at differentiating a log base e of a function. This is also written as y equals ln f of x. It just means that it's a base e. So dy on dx, the basic rule would be f dash x on f of x. So you put the derivative on top and the function on the bottom. So for example, let's use this to differentiate the following. Let's go ln of x squared plus 1. Okay, so when I differentiate that, derive the function, which is x squared plus 1, so that becomes 2x, over the actual function, which is x squared plus 1. So if you differentiate ln of 2x minus 1, then the derivative of that is the derivative of 2x minus 1 is 2 over 2x minus 1, so over the function. Ln of x cubed minus 2x squared plus 1, the derivative would be derive the inside, which is 3x squared minus 4x, and the derivative of 1 is 0, over the original function. So let's look at ln of, so we had ex plus 1, so the derivative of that would be, derivative of ex plus 1 is ex, with the derivative of 1 is 0, and e to the x just goes to e to the x, and it's just over e to the x plus 1. Okay, so if you had ln of x squared plus 1 on x squared minus 1, for example, when you go to do the derivative of that, it's a quotient, so it makes it quite difficult. So what you can do is you can use your log rules to actually simplify this first. So if you had log AB and it was multiplied, logarithm of a number is just the indice or the power you raise the base to give that number. So if you're multiplying, then you're actually adding the logs, because you're adding the indices. If you are dividing, you can split that up by going log A minus log B. And if you have a power, log A to the power of n, you get n log A, because the n comes down and it becomes a times. So looking at this one here, what you're probably better off doing first of all is to, because it is a division, you're better off splitting it up and going log of x squared plus 1 minus log of x squared minus 1. And then when you now go to differentiate this, you differentiate them separately and it's much easier. So the derivative of x squared plus 1 is 2x, and that'll be over x squared plus 1, and the derivative of this one would be 2x, and that's over x squared minus 1. So you could just leave it like that, that's the actual derivative, but it is nice to simplify it. So you could simplify it by getting a common denominator, so you times that one by x squared minus 1, minus 2x this one by x squared plus 1, all over x squared plus 1, x squared minus 1. So you end up with 2x cubed minus 2x, and then minus 2x cubed minus 2x, minus 2x cubed minus 2x, and that's all over x squared plus 1, x squared minus 1. So you can see they go out and you get minus 4x on x squared plus 1, x squared minus 1, and that's the derivative. Okay, so if you were differentiating something that has a log but maybe has a square root on it like that, it's a bit difficult to find your f dash x. But if you use your log rules, I'm going to write that as a power of 1/2, because the square root's a power of a half. There's no 2 there. It's not showing, but the 1's on top and the 2's on the bottom. The half comes down the front. Half ln 2x minus 1 ln 3x plus 1. Okay, so looking at that there, then when you differentiate this, you get a half, and you get 2x over 2x minus 1 minus 3x plus 1 is 3 over 3x plus 1. And then simplifying this, that's a half. I'm just going to make it simpler because it'll make it a lot nicer. So you times this one by 3x plus 1 and this one by 2x minus 1. So it's 2 times 3x plus 1 minus 3 times 2x minus 1. So it's a half. So you get 6x plus 2 minus 6x plus 3 over 2x minus 1, 3x plus 1. So it's 1/2, and simplifying the top, the 6x's go out and you get a 5. And then you've just got 2x plus 1, 2x minus 1, sorry, 3x plus 1. That's a minus there.